Okay, so I'm going to talk about vertical and horizontal shifts in this video. So vertical refers to y direction. If we have, let's say, a coordinate system, this is x, y. So vertical is this direction and horizontal is this direction. So whenever we are talking about vertical, then we always refer to the y values, and whenever we're talking about horizontal, we're referring to the x values. So okay, let's start with the vertical one. So let's say we have a function y equal x. So these are simply just the y values. F of x means a y value. So if I just take a number, right? So let's say this could be any type of graph, right? So we're just going to call this a parent function. So y equal f of x is a parent function, let's say. So whenever we have a, let's say we have a c that is positive, this is a constant real number, then y equal to f of x plus c is going to be a vertical shift upward. So this will be, or you can simply just say up by unit c. So this is vertical shift upward by c units. Positive. Then c could be negative as well. So if c is negative, so then you can just say, okay, if c is negative, then you're subtracting it. Sorry, c is negative. If c is a negative, then you're subtracting y equal f of x plus c is also a vertical shift, but this time it will be downward. Vertical shift is downward. Okay, I'll just give you guys examples to illustrate this situation. So let's take this parent function. So let's say we have y equal to x squared, which we know that this is a parabola. The vertex of this parabola is at the origin like this. Okay, so if I just, let's say, add a number here, if I say x squared plus 2, then I'm just going to shift each point, okay, each point. So I'll just pick a random point on this graph. Maybe this will have better. So let's say just pick a random point, x, y. Then what this means that I'm going to take x, y, and then x, y, just a random point, will be x is not going to change, but I'm adding 2 to the y value. So 2 is added. So this will be y plus 2. So this is sort of like a formulation of each point on the graph. So we're just going to add. So if I make a quick table here, let's say for the original one, for y equal to x squared, okay, and then I'll make one for y equal to x squared plus 2 here. Okay, so let's say I take a negative 1, 0, 1. Let's just keep simple like this. Okay, so negative 1 squared is 1, and negative 1 squared plus 2. So plus 2 means you're adding 2, so it becomes 3. So this is 0, this is 1, so I'm keep adding 2 here, 2, 3. So you see, I'm just adding 2 to get the next one, adding 2 to get the next one. So therefore, every point here is going to be shifted. So if I just take x squared, so negative 1, 0, 1, so that's like sort of like 1, this point, like that. Now it's going to be shifted, right? So now I have negative 1 is going to go to 3, 0 is going to go to 2, and this is going to go to 3. So you see the graph is shifted by 2 upward. Okay. All right. So you can formulate it whether if you want to understand it better. So a quick small table might also help to understand this. Okay. All right. So now let me give you guys another example. So let's say I have this function. So f of x equal, so here's another example. F of x equal, this time, let's say we have square root of x, and I'm going to say minus 3. So this is a parent function. This is a parent function square root of x. So let me just put that over here. Okay, so that's this. Y equal to square root of x is this. And if you subtract 3, you're just going to pull this down by 3. Every point is moving down. So pick a point, this is going to move down. You pick a point, this is going to move down. Every point is moving down by 3. So 1, 2, 3. So this is the vertex. This is the starting point. And then every point move down. So therefore, you're going to have a point like right here. So the graph will look like this. All right, perfect. So now let's go to the second part. The second part is the horizontal shift. So in horizontal shift, the x values are going to be affected. So again, I will just say this y equal f of x is the parent function. Let this be the parent function. The parent function means like simple, like x squared, x cubed, square root of x, absolute value of x, those type of functions are called parent functions. Okay, let's y equal f of x be a parent functions. Now we have two forms to consider. So the first form is this. So I have y equal to f x minus c, and then I have y equal to f x plus c. So if you do minus c, this means, so okay, assume that c is positive here in the beginning. So if you do minus c, then this means, this means horizontal shift to the right. Okay, so horizontal to the right, horizontal shift to the right by c units. Okay, by c units, and this is horizontal shift to the left by c. Okay, so if you like set this to 0, you get x equal negative c. If you set this to 0, you get x equal to c. So if you get a positive number, then it means it's right. If you get a negative number after setting it to 0, it means it's to the left. So let me give you guys an example. So you see the operation is done to the x values. If operation is done to the x values, it's always left and right. If operation is done to the y values, it's up and down. So let me give you guys an example here. Okay, so let's take this. Let's say we have this function f of x equal absolute value of x minus 3. The function is absolute value, so our parent function in this case is the absolute value function, and the graph of absolute value function is this. So let me put this. I'm going to always remind you the parent functions in case if you forget it. So that's this. It's like a V shape, right? V shape. This is a straight line. This is a straight line. Okay, now minus 3 means if it's x minus 3, so set this guy to 0, right? If you set it to 0, you get x equal 3. So that's a positive number. So that means we're going to the right. So this is going to be translated to the right, which is 1, 2, 3. So I translate it now. This is my new vertex, and then I will just copy down the same shape. That's it. That's just one operation, right? So if you formulate this, you will say this. You will say, okay, I pick a random point. I pick a random point here called xy. And this random point is going to be translated. Okay, so what I did to the x value, I add 3 to the x values because I went to the right, right? So plus 3. And then the y value didn't change. Y is the same. So you can formulate the points this way. And if you just pick a random point on the graph of absolute value function, and you can just use that. For instance, let me just give you an example. Let's pick a point. So if x is 2, then absolute value of absolute value of 2 is 2. So now x is 2, y is 2. So put it here. 2 plus 3, this will be 5, and this will be 2. So 2, 2 is on this graph. 5, 2 is on this graph. So that's how you can formulate it easily as well. Okay, let me give you another example. So let's take this. Now, actually, I can just give you an example with the plus now. So let's say we have this function, square root of x plus 2. So like I said, the operation is done to the x value, right? Because 2 is added to the x value. So set this to 0, x plus 2 equals 0, x equals negative 2. So you get a negative number. So that means you're going to the left. Well, the parent function is this. Okay, let me put the parent function this way. So the parent function is this. Square root of graph is like this. This is y equals square root of x. Now I'm going to the left by 2. So left 2, 1, 2, and then I'm going to copy down the same exact picture, right? So -2 is right here, so same exact picture here. Now, if I formulate this using the random point, so xy is a random point, then if you translate this, okay, what I'm doing, I'm subtracting 2 from the x value. So this will be x minus 2, and y is going to stay the same. So I can formulate it this way if I want to, okay? So now one more example, I will just give you the now combine this two type of shift. So let's say we have this example. So let's say f of x equal 1 squared minus 3. So I mixed two operations here. So whatever is, like this is sort of like, following order of operations. So you do, like remember that PEMDAS thing. So PEMDAS will also work here, because if you have more operations to do, then you sort of have to follow a certain order. So here I have a parentheses. So I will do parentheses and then exponent and then the other stuff, right? And the multiplication and division and so on. But here I will just do the parentheses. So what's inside the parentheses is always going to come first. So I'm going to do this first. And that's +1. And +1 means to the left, right? If it's x plus 1, that's to the left. So now I will just write down I will list my operations here. So left 1 unit, left 1 unit. And then it's -3, and -3 is outside. So if it's outside, then it's going to be done to the y value. So it's the -3. So that means down 3. Down 3. So it's that simple. And our parent function is x squared because you have a power 2. So it's a parabola. Here's the parabola. I'm going to put it again to remind you. You will see this many times. Y equals x squared. Now I'm going to use two operations. So my first operation is going to be left 1. So 1, that's -1 here. This is the picture, right? First operation. Then my second operation is going to be down 3. So this is where I left. I'm going to pull it down from that point. So 1, 1, 2, 3. I pull it down here. And then same shape, right? See, I get it in two operations. Now let me show you on the random points too, if you're curious about like generating points, so you can do it this way. So I pick a random point on the parent function x, y. Now what I did to the x, well, I subtract 1, so it's going to be x minus 1. What I did to the y, and I subtract 3, so that's y minus 3. Okay, so let's pick up random points. So if this is 2, well, because this is x squared, so I will square it, that's 4. So x is 2, y is 4. Now plug it in. If x is 2, so 2 minus 1, this is 1. 4 minus 1, 1. So 1, 1 will be on this graph. So this is going to pass through 1, 1. So like I said, you can make your graph much more prettier. Mine is not very pretty because I didn't really do it based on point. I just did it based on the shift. But I can generate any point I want using this formulation and then make my graph more prettier. Okay, so we'll work on that as well. So for this video, this is it. So